Okay, so some test topics. Graphing, definitely parabolas, not just the up and down ones, but also the sideways ones. How did you know which way the parabola goes? Which one is squared? So if it's the up and down one, what variable is squared for that one? That's the x squared parabola. Right? Because that's sort of what you think of as like the normal parabola, y equals x squared. And if the y is squared, that seems weird, and yeah, that seems weird. You get a weird parabola. You get a sideways parabola.
So like when we like have to graph, will it always like only give us the form with like the directrix, like that square thing, or will we have to like actually like graph like we were graphing when we did the video?
Oh, okay. It's going to be the format. I'll show you the format, but it'll be the P type of graphing, where you find the focus, the vertex, the directrix. Yes. We also did some square root graphs. That was a new parent function for us this unit. And the key points, you don't really have to memorize the key points if you know what square root means. The square root of 1 is 1. But what should my next set of points be? 4, 2, right? Because I don't want to take the square root of 2. I'd rather take the square root of 4 and the square root of 9 and so on. And then all the usual translations about left 3 and up 5 and stretched and flipped and all those things to go with that. What will be given to you on the test is that basic format of the parabolas. The x minus h squared equals 4p y minus k. Let's see, obviously that has an x squared term in it, so that would be either an up parabola or a down parabola. And the other one would be y minus k squared equals 4p x minus h. The y is squared, so that makes it the weird ones, the left to right parabolas. Oh, I guess this should be clear. What's given is not the pictures with it, just the equations. And we'll assume you can figure out which one's left, right, and up, down. And then we did this a little bit on worksheets. We did it a little bit out in the hall as well, where you write equations from information. It gives you a vertex, or it gives you a focus, or it gives you a directrix, or some combination of those things, and you figure out the pieces to write an equation. Exponent rules, another big topic. There was a couple of worksheets on that. Some of the problems were ridiculous because it had numbers and then 3 sets of letters and parentheses and negatives, and give you an easy one to look at here. 2x to the negative 2 cubed over 4x squared. I would say that's on the easy to medium side of the types of problems, but just to remind us what's going on there. So I think I would cube the top first. Let's pick on some people here. These are fun because I call on lots of people. Gotta find people who are here though. Ava, how about 2 cubed? 8. Dawson, how about x to the negative 2 cubed? Power to a power? It's not 2 cubed. A power to a power is multiply? Good. Negative 6. And then in the bottom, Emmy, why don't you square all of that for us? Double up your workload here.
Just 16x squared.
Good. I was hoping you would say 16x squared, not 4x squared. You got to square both pieces. Okay, well that means we need to simplify the numbers and then simplify the letters. So, Madison, how about the numbers, the 8 and the 16? What's that become? 2, top or bottom? Might even help to just cover that up. What does 8/16 reduce to? You're right, 2, but 2 in the top or 2 in the bottom? 2 in the bottom. Rayanne, how about the x to the negative 6 and the x squared? How do those combine? Where does that end up?
Does it become x to the 4th on the bottom?
Ooh, that's what someone in the first period said. Maybe I'm asking you to do too much at once. What does that negative 6 do? What's that negative 6 exponent do? Flips it to the bottom, so that would put x to the 6th in the bottom.
Oh, it's x to the 8th.
There you go. It's all right. It's why we're doing it. We're a little rusty this morning. Well, someone's going to get an easy one, but Giant, what goes in the top, or do I leave it blank? Put a 1 there. All right, so exponent rules. We did a whole bunch of those. Factoring. Man, there's lots of types of factoring too. So I'm just going to list the types, and we'll do examples of some of them, not all of them. GCF, what's GCF stand for? Greatest common factor. Always look for it first. Always look for GCF first. Because it simplifies your problem. It makes life a little easier. So if there is a GCF, look for it, or we don't know if there is, look for it first. Probably the next type of factoring you did was the kind of the simple or normal factoring, you might call it, ax squared plus bx plus c. And what in particular about that would make this an even easier factoring problem? What about A, B, or C would make life easy? No C. I wasn't even thinking about that. But yeah, no C would make life easy. Factor out an X. If A equals 1, then life is a little easier. If A is prime, life's not too bad, right? If that's like 3x squared, not terrible. It's when A is 4 or 6 or 12 that things get kind of complicated. Difference of squares. So something like x squared minus 9. Benji, how about x squared minus 9? What would that factor to? I'll set it up for you if you need a hint.
X minus 3, x plus 3.
Good. X minus 3 and x plus 3. What about a sum of squares? I don't even want to write it down because you can't factor, so I shouldn't put that in factoring. Put that over here in not factoring. X squared plus 9 does not factor. Always one of the favorite test questions is to put that on there and watch students come up with all sorts of ways to wrongly factor that thing. What you can factor with a sum is cubes, sum and difference of cubes. So let's see. Let's do a sum. let's go 8x to the 6th plus, you tell me, what number would I need there? What's an example of a number that could go there that would allow me to factor using sum of cubes? 27 is a good one, because that's a perfect cube. For whatever reason, I don't like factoring in a line, especially for cubes. I like factoring underneath because it helps me think about same sign, opposite sign, always positive sign. I don't know, it helps me think about taking the cube root of those pieces. So, Jacob, what's the cube root of 8x to the 6th? I like x to the 2nd. 2x to the 2nd, good. Make sure you take the cube root of both pieces there. Noah, how about the cube root of 27? 3. And then, I don't know, it's been a while, so I'm hesitant to call on somebody for that first blank. What goes in the first blank? Anybody? The first one squared. So I'm going to square 2x squared. So, Keegan, if I square 2x squared, what do I get?
4x to the power 4.
Yes. Good. Squared both of them. 4x to the 4th. How do I get what goes in the middle? Multiply the 2 together. So, Andrew, if I multiply the 2 together, what goes in the middle? 6x squared. And then, Abigail, what goes in the last spot there? See if this square the first, multiply the 2 together. It's like a little bit of symmetry going on here. Square the first, multiply the 2 together. Square the last one, and get 9. Now, almost nobody ever factors or ever checks that thing, because it would be kind of a pain. But what could you do if you wanted to check it? What would you do if you wanted to check that you factored that right? Multiply it all out. Again, hardly anybody does that because you'd have to do 2x squared to everybody and 3 to everybody and collect all the like terms. But there is kind of a shortcut check. It's not a complete check. But if you do the first terms, 2x squared times 4x to the 4th, what do you get? 8x to the 6th. So it's like, okay, I feel somewhat decent maybe. And if I multiply the last terms, 3 times 9 is 27. So that's not a full check, but it's better than nothing. And you probably don't want to take the time to make sure everything else cancels out. But that's an easy way to check, kind of a half check there. All right, we did factor by grouping. Let's see, 2x squared minus 2xa minus 3x plus 3a. How do you think we should group those? 2 and 2 or 3 and 1? Anybody? 2 and 2. How did you know that, though?
Because the first two are the same and the last are the same.
You kind of just have to see it and like, oh yeah, those look like similar and those look similar, so that looks like a 2 and 2 grouping. And if you tried to group 3 and 1, like that wouldn't get me anywhere. So let's do 2 and 2. So, Karis, what could I factor out of the first two? And what does that leave? Good. Dylan, what can I factor out of the second two? Yes, kind of. Why kind of? Anybody? Let's do a -3 because that will help the insides match up. And that's sort of the midway check that, hey, I'm doing this right because I got the same leftovers. So I'll factor out the x minus a, and that leaves 2x minus 3. And then what most of our factoring problems are like multi-step, so there's more than one step in them. 2x to the fourth plus 4x squared minus 6. Carter, what do you want to do first on that one? Factor out a 2. X to the fourth plus 2x squared minus 3. Let's see, I think that will factor further. What two things could I multiply to get to x to the fourth? Squared and x squared. And then it sort of turns into a normal factoring. I need to multiply to get negative 3 and add to get 2. So, Jenna, what could I do to accomplish that? I want to multiply to get 3.
Oh, 3 and 1.
3 and 1. And then what do the signs need to be so that I land at a positive 2?
-1 and positive
Good. Giant?
I'm sure I've also done like y equals like x squared. And then you could just like substitute like a y. And
Oh, okay, yes. The substitution method, yes. Make sure you plug it back in at the end, but yes, you can do that. He was saying, so change it into y squared plus 2y minus 3, because that does look easier to factor, where x squared was equal to y. Yes, you can do that. And then you'd put the x squared back in. And why am I still not done with this problem? Yeah, I can do this x squared minus 1 thing. So this is one where some, hopefully not many, are going to lose some points because they're not going to factor it all the way. They're going to stop short. This was like 3 different kinds of factoring rolled into one there. So partial credit to be had, but keep looking to see if you can factor further. Okay. Big picture wise, if any of that looks, or if you're thinking about studying for the test, those first 2 topics are on today's review. Monday review. So the graphing stuff, parabolas and square roots. Again, it's a 2-day review. The rest of that is on the Tuesday review. Okay. I want to do one problem off the review, and then we'll do something else that's kind of fun, kind of different. So let's turn to today's review. And let's just do that first one, because, man, it's been a while since we graphed a square root function. Let's see. Man, I might get through everybody today. Jeremy, tell me something that's been changed from the original, like from the parent function to get to number 1.
Compression.
All right, so vertical compression of 1/2. Madeline Reeves, tell me something else that has happened.
It goes up 3
Up 3. And Madeline Bull, what else has happened?
to the left 2.
Left 2. All right, so now let's see if we can put all that together. Left 2, up 3. But Ella, what's like my table of values or table of directions or key points? How do I get to my next?
1, 1, 4, 2.
Good. 1, 1, 4, 2, 9, 3, and then 16, 4 if you really want to go crazy, but that's probably off the graph at that point. 25, 5, 36, 6, and on and on. But the point is, you don't really have to memorize that. These are all square roots. Okay, there's one more thing I need to think about, Grace, before I graph this. Jeremy told us we'd vertical compression by a half, but like, how does that affect my ordered pairs here?
Multiply the half to all the y's.
Good. We'll multiply the y values by a half. That'll squish it down. So 1/2 and 1 and 1.5, and we probably won't even get out to 16. But. So over 1 up a half, over 4 up 1, over 9, 2, 4, 6, 8 up 1.5. So a very squished square root graph. All right, so that's a pretty good review of a lot of stuff.